When we are talking about robots, we can think about those kind of rigid robots, but actually there's a new class of robot is called soft robots. Ultimately, the goal of the soft robot is like we want to achieve like autonomy and also intelligence. So our soft robot is a very simple shape. It's like looks like a rotini, like a Italian pasta. So it's like you have a ribbon, right? Just stretch and then twist. So soft robots are made of liquid crystal elastomer. So the good thing about this material is they are smart. They are intelligent, means they can respond to the light, they can respond to the temperature. So when you put this one in the light or on the hot surfaces, right, and then this material gonna shrink, in one direction and expand into the other directions. So that means they can harvest the energy from the environment. So that's what I'm calling is a self-powering, because you don't need a battery. For now, we are looking for the application. For example, like a desert. It's very harsh environment because it's a high temperature, right? And also because of the sand. The boundary of this twist is like a blade. Actually, this blade can help them to prevent from sliding, because you can think about it's so challenging to work on sand, right? It's very high. So this temperature can be enough to drive the self-rolling of this soft robot. So they can self-power and then to self-roll. But there's another task, or that's aim for us is intelligence, right? How to test intelligence? We have done some experiment. When you put an obstacle, for example, a glass bottle in front of that, when it's get in contact with this obstacle, seems like they are talking to each other. It's like communication. And then all of a sudden we find this ribbon gonna be untwist and also snap. So snapping is like interesting phenomenon often observed in nature. For example, the Venus flytrap, right? So this one also can have a snapping. So then when it snaps, that means they can reflect or redirect its moving directions. So that's why, you can achieve this kind of intelligence. They can always, make their decisions spontaneously and then to eventually find their way out. In this work, we do achieve a certain level of autonomy and intelligence, but actually there's some, we do find that there's some part of the drawback of this soft robot. We find actually if we put this soft robot in a little bit more complex mazes, we find it's very hard actually for the soft robot to escape. So we are working on this soft robot to make it apply to the more complex environment.